by default it is getting disconnected, so I need to make sure that the tab should not get unlocked. Okay, so let's move on. So we want to design a circular queue. So I think you can able to do it. Let's see. You will be given a queue size which is as k. So let's say k equal to 3. So it means the queue size should be 3. Let's say you have added element 1. So 1 is added. Then you have element 2. Then you have element 3. So now if you ask friend, this is my friend and the 3 is my rear. So the last element is the rear. Now later, if I add element 4, then what should happen? The queue is full, right? The queue is full, so that definitely you can't add. That's what he's trying to say. So if the queue is full, you cannot add. Then in the problem statement it is saying, so you can go through that. And if you definitely this will return false because you cannot add the element because the queue is full. Now if I do dequeue delete, then the queue contains 2 4 2 3. Then if I try to call add method 4, then queue this value becomes 4. So then this is going to be front, this is going to be rear, right? Can you tell me how to design this circular queue? Do you understand the problem statement?
Where did we make it circular?
We didn't make it circular, but does it following circular queue concept?
No, right. Ray should point to front. Connect to after where AM time should start, right? Is it not like that?
Conceptually, that's how it should be. Even in this case, 4 should be connected to 2. Conceptually, that's how it should be, but do we really need to do that?
I think if we know the rear and we have maintained the size of that queue, then size plus 1 modulo the capacity can be called as the rear end. That's how the rear and the front can be connected.
Correct, right? So, for example, that's how, but here there are no indexes now. But to find that element, it needs to be, you need to have a indexes, right? But there are no indexes. Maitri, I understand.
Yeah,
your
every time we insert
question.
an element, we can maintain a counter.
Yeah, but how do you find out front and rear in constant time?
To find the rear, like every time we insert a new element, we can increment the rear value, and we will maintain the capacity also, like how many number of elements you have inserted so far. So to find the rear, what you can do, whatever the rear value have, we can add the module of the capacity, so it will give the rear element.
Let's say here, initially when you, this is how it should be, right? So first you have added element 1. Okay, so 1 is added. So in this case, the element count is 1. And what is front? 1, right? Rear also 1. Okay, so you have added element 2. Okay, in this case, front will be 1, rear will be 2, and count will be 2, correct?
Yeah. Okay. So rear plus 1 modulo capacity.
I understand that principle. Let's see the complexity. So front will be 1, rear will be 3, count will be 3, right? Now, yes. What is front? Okay, front is this one, rear is this one. Now I deleted it. So when I delete it, now this is 2, 3, right? Now rear remains 3. How do you find out front?
Front will move one step forward.
Yeah, how do you do that? How do you do that? Which data structure do you go for? So I want to find out this front in constant time, right? Next front when I move.
I mean, to insert the data, we can maintain array, and for the front and the rear and the size, we can maintain 3 different variables.
Perfect. So that's the best way to solve this. the second way is is it not like linked list?
Yes,
Is it not like
exactly.
linked list? Whatever, how did we design queue with linked list earlier? Is it not the same? Somewhere we did it right. Is it not
It's the same, just with one variation that the rear is connected to the front.
Yeah, ideally the circular queue should connect, rear is connected to front, but there is no use case here. You don't have to do it necessarily. Do you necessarily do that? So if you go with linked list, in this case the size is 3, right? So if you want to delete, so what is your point? You just need to move the head, right? So earlier head is here, rear tile is here, head moves here, tile will remain same. So head is pointing to front, tile is pointing to rear, and you just decrement the count. Next time when you insert a new element, so then 2, 3 and something 5, this is going to be tile, this is going to be head. Correct? Is that clear, Maithili? I understand that your question is circular queue means the last one should connect to front, but his point is in a circular queue the front and rear will keep on change, right? So when the queue is filled, if you want to delete, then once you delete the front, it will just move further. So through just simple linked list code, you can design a circular queue even though you don't maintain. Of course, you can make sure that tile dot next equal to head. That is fine. It's like a loop, but you need to take care of edge cases. Uh, that's one way. So you can come up with simple linked list, design a circular queue. And the other way is what Ajay suggested. So you have k equal 3. So let's say k equal 3, so that the size is going to be, definitely the size is going to be 3. So 0, 1, 2. So what I will do, head is always going to be 0th position, right? No matter where it can be, right? Head is always going to be 0th position, right? Yes or no?
Yes.
Yes.
And okay, so let's see how can we do that. Okay, so let's say I add 1. So when you add 1, where it will be for the first time? So you will have two elements. One should be head, other should be rear, other should be count. There are 3 variables which are representing head, rear and count. So count is representing how many elements present in the queue, and head is pointing to the first element, rear is pointing to the latest element. Okay, so let's move on. Initially where head will be, please? Initially where head will be?
0 at the mix.
Okay, so we can make sure that it is 0. Where rear can be?
Pointing to the same.
0
As we don't
index.
have any elements.
So definitely it should be -1, right? So you don't have any elements. Correct now?
Yes.
So ideally you can say head also -1, but to make it work, so initially head is 0, rear is -1, count is 0. So count is 0 means if someone calls front or rear, definitely you will return -1. So let's say you add 1. So when you add 1, so just add 1 here. Just increment the rear because you inserted first element, right? So that you increment the rear by 1. So this is how it should be. So you will have head, rear and count. Okay, so head is 0 and rear earlier -1, you added 1, so incremented by 1, so which is going to be 0. Now count will become 1 because you have one more element, you added one more element. Add 2, so 2 means what? Definitely 2 will be presented into that, so rear will be 1, head remains same. And when I add 3, then definitely it is here, so it is going to be rear plus 1, so that rear becomes 2. Now when I add 4, so now where it should be going? So here count will be 3 here. So where it should be going? To the first position, right? It should be replaced with the first position, right?
Yes.
So actually I should know, if I add 4 here, ideally according to the problem statement it will return false because your queue is full. Now when I delete, if I delete, where it what should move? If I do delete, what it should move?
Head equals to head node next.
One will go up.
No. Head increment to 1.
Delete means you don't have to delete, right? If you delete from the array, definitely what will happen? If you delete from array, then the shifting of elements take more time, right? So that don't delete from array. You just move the head by 1. So head will be pointing here. Rear is pointing here, correct? Now head is this one, right? Correct? Maithili,
Yes.
is that clear?
Yes, sir.
Now if I add 4, where it should add?
In the first only.
Then what it is going to be?
0th.
What it is going to be?
4, 2, 3.
Obviously I add 4. Okay, so what will happen? So obviously it should add here, right? How do you find out that? Rear is 2 now.
Yeah.
Rear is rightly pointing to second index, right? Now I should add to this position. It means what is happening? One cycle is completed. So rear is pointing to the first cycle. One cycle is completed. Again it has to start from the same cycle, right? Simply to find that, so rear plus 1 modulo n. So n is 3 here. So if you closely see 3 percentile by 3, so which is going to be 0. It means now rear is pointing to 0th position. At 0th position you will add 4. So this is my rear. Do you understand this? This is more critical part. So head is pointing here, rear is pointing here. Kalyan, Maithili, is that clear? This is the most critical part. So then if you try to call, now again if I do delete, what will happen, please? If I call delete, so what should I do?
Move the head.
Move the
again.
head, right? So for head also same concept. So head plus 1 modulo 3. So definitely in this case head is 1, right? So 1 plus 1 modulo 3, so which is going to be 2. So move the head here. Now rear is here. So if you closely see, this is head and this is rear. So you hardly have 3 and 4. Now if I again add 5, so what will happen? You will move the rear. So rear will come here. So this is how it should be. So head is here, rear is here. So it means what are you trying to do? You are trying to use the same array and mimicking the circular queue concept. Okay, this concept is very important when we try to solve circular related problems in future. But hope you get this point, right? Maithili, Ajay. Is it confusing?
Yes, Shanu, clear.
Maithili, is it confusing or clear?
Like head value, why should we calculate? Like we can just move ahead, right?
Okay, this one, huh?
We do that formula.
Okay, but head is here now. Head is 2 now. Head is at second position now.
Then
If I
we
delete-
reset it to 0.
We reset it to 0.
I didn't understand why we are coming up with that formula. What's the
Because
innovation?
when you delete first round of elements, right, it is again yeah, in that case you can reset it to 0. The same thing can be done through this formula, right? So you are saying when head is equal to n minus 1, you will just reset to 0. Similarly, when tail equal to n minus 1, you will just reset to 0, correct?
Yeah.
Yeah, that will also work and this will also work. Both are same.
Okay.
Yeah. Can you implement this problem? Others, can you try to implement this? Or shall I write the code?
Write the code.
Okay, so this is my integer array, right? So you will have q. So this is my q. So definitely the q is going to be my new K size, it should be K size. And what are we trying to do? So we are trying to take head, and we are trying to take tail, and what is our job? We are also having size. Okay, so definitely tail, which is -1, because we want to add +1 and add, and head initially pointing to 0, and size is initially 0. And what we do, NQ, right? So if you want to add elements, if your size is equivalent to Q dot length, definitely you can return false. You cannot add, because when the size is equivalent to your queue is already filled. Otherwise, what you do, so you just find out a tile. So as what Maitri said, if tile is equal to Q dot length -1, so just make sure tile is equal to 0. Otherwise tile equal tile +1. So this is how it should be. So this will also work. Rather than this, you can apply the same principle simply like this. So tile equal tile +1 percentile by Q dot length. That's it. So you can get that. Then simply you can have Q of tile, which is equal to value. That's it. Then dq means what? You can simply delete even. So when you add, so what is our job? So we need to increment this size, and when you delete, you just decrement the size. And let's say if size is equal to 0, then you can simply return false. So you don't need to delete because it is empty. Otherwise, what is our job? So we just need to move the head. Head is going to be head +1 percentile by Q dot length. That's it. So finally, if it is head, you just return Q of head. If it is rear, you just return Q of rear. What do you call tail, right? So it is tail. And if it is empty means return size is equal to 0. If it is full means return size is equal to Q dot length. Clear? Others clear, please? So just to avoid, just to make the code cleaner, you can do that if else logic also, it works. Somewhere we missed the return statement. Here it is return true. Here also return true. Okay, let's run. Somewhere we did a mistake, and this was really bad input. Okay, so where it is false, false, false. Front is returning 0, but it should return -1. Yeah, tell me what is the mistake. Can you tell me? Front is returning 0, but it was returning -1. Expected is -1, but returning 0. Tell me, please.
We need to calculate the head properly.
So actually, in this case, right? So when you are returning front, if size is equal to 0, return -1. Otherwise, return the actual value.
Actual head. Yes.
Similarly for this guy also. Okay, so because we are trying to manipulate the same input, right? So that's how it's failing. Yeah. So you should be very quick in understanding the bug. So if you are very clear on the algorithms, you can easily figure that out. Okay. Let me solve one more problem. Today our laptop didn't support us. Okay, so can you tell me how do you solve it? So it's a concept of moving average. Uh, so what he's trying to say is, okay, here there is a code. Okay, so what he's trying to say is you will be given a queue size. You have a data stream. You will be given a data stream size, and you keep on add the elements to the queue and data stream. You can say you will be given a data stream size. You will be keep on adding elements to the data stream. So we need to find out average of the data stream. So that is what it is trying to say. Let me explain the problem statement. Okay, so let's say here he has given a data stream size. So let's say the data stream size is 3. So we need to find out average of the stream size. If the stream is filled, we need to remove the older elements. So that's the problem statement says. Let's say this is my stream size. So this is my stream of size 3. I have added element 1. Okay, so 1 is added. Now if I want to find out average of the data stream now, so definitely it is going to be 1. Correct? Correct now? Yes or no?
Yes.
Ajay, is that clear?
Yes, you know.
So now I have added one more element 2. Now in the data stream I have 2 elements. So if I want to find out average, definitely it is going to be 1 plus 2 by 2, so which is going to be 1.5. Now I have added one more element 3, so definitely it is, if I want to find out average, so which is going to be by 3, so which is going to be 2. Now I have added one more element 4. Now if you closely see, my stream is filled, right? So he's saying the same thing. So given a stream of integers of window size, calculating the moving average of all the integers in a sliding window. So what he's trying to say is you have the stream size is 3 now. Now you have added one more element. Now stream is filled. When the stream is filled, remove the older element and find out the average of remaining elements. So that's going to be 2 plus 3 plus 4 by 3, so which is going to be 3 again. Now if I add one more element 5, so we need to remove the older element, then it is going to be 3 plus 4 plus 5 by 3, so which is going to be 4. He is expecting in double, so we just written in double. So how do you solve it?
Using queue.
It's a simple queue problem, right? Yes or no? But how do you find out average in constant time? So one way is what? One way is simple, right? So it's a simple queue concept. So first you add element 1 to the queue. Now if I want to find out average, so I can take the sum of elements in the queue by the size of the queue, so which is going to be 1. Now I have added element 2. Now again I have find out the sum of the elements in the queue, so which is going to be 3 by 2, so which is going to be 1 by 2, 1.5. If I add element 3, again I find the sum of the elements from the queue, so which is 6 by 3, so which is going to be 2. Now when I try to add element 4, now I added element 4, my queue size is greater than k, so which is equal to 3, so then we delete the first element. Now again find the sum of these remaining 3 elements by 3, so which is going to be 3. But how do you find out sum of elements in constant time? But in this case, which is going to take linear, right? Yes or no? So we need to find out sum of the elements in constant time. Ajay, how do you do that? Do you understand the time complexity here? If you do this, adding will take linear, but if you want to find out average, so we need to find sum of elements from the queue, so definitely it is going to take linear.
N into n by n plus 1 by 2.
No, it is not always sequential elements, right? You can add any
Moving
element.
variable, global variable. keep deleting.
Okay, so I'll take a global variable. So definitely when you add this element to this global variable.
Yeah.
Okay, so first I added 1, then I added 2, then I added 3. So definitely this keep on updating. So 6 by queue size is 3, so definitely you'll get 2.0, right? Now when I add element 4, then what should I do?
Then we DQ will get the element, right? Remove
Right.
that sum from.
We need to remove the.
Yes. So first thing is you add current 4, fine. Once you add current 4, so this 4 is also present in queue. When you delete the element, right, so it will return 1, na? So minus that 1 here. So that this first element will be removed, so that you will get the remaining elements. So which is 9, so which is going to be again 3. Understood, Ajay? So simple. So you can simply handle through a simple variable. Let me implement that. So what is the time complexity now? What is the time complexity of average now?
Order of 1.
Constant.
Yeah, so it's going to be
Constant.
Yeah. So if you see, this is my size. So definitely you will be taking a queue as well. So simple, what you should do first, you will add whatever element which is coming in, add to the sum, then add to the queue. Then in case if queue dot size greater than size, then simply you can subtract. So sum minus equal to whatever value you pop the first value from the queue, subtract it from the sum. You can do this way for more cleaner way. Done. So that's it. So finally you can return sum by queue dot size. Is expecting in double, so just multiply with 1.4. That's it. Clear, buddy? Yeah, I think you can solve with this knowledge. You can easily solve other problem. Where is it? So you can solve this number of recent calls. You can easily solve it. Can I go with this time needed for buy tickets, or do you want to continue tomorrow? This is also easy problem, but I'll explain the concept. Let's see how do you want to implement it. Uh, is it okay to continue, or shall we continue tomorrow?
Tomorrow.
Okay, no problem. Yeah, please practice all the 4 problems. Tomorrow, actually, don't miss tomorrow's session. So tomorrow we will freshly start with breadth first search on queues. Actually, it's a concept of queue. So these next 3 problems are into BFS. So we'll talk about them. So don't miss tomorrow. And if possible, try to come up with the solution by your own for 2073. If you are unable to do that, I can explain tomorrow. That's it. Yeah. Any questions?